All right, so continue for today. Hi, Assalamualaikum, everyone. I mentioned that you're supposed to just read, but I think it's better to understand rather than just to read yourself, right? Just to go through, it's just 50 minutes. So today it's about sets, which is actually a revision. You have seen sets and subsets before. So just to review, yeah? Okay. Okay. I think also Hannah and Shiham, you have seen about sets, even from school, right? So sets. A set is a well-defined. A set is a well-defined collection of objects. All elements or members. Well-defined collection, meaning when you take one collection of object, you can define whether it is a member of a set or not. So it's not just a collection of object. Yeah. For example, we learn about sets about numbers, right? Then you know it's a set. What is not a set? What kind of collection that is not a set? Let us go beyond numbers. Okay, numbers, you know, it's a set of integer, it's a set of real number, but let's go beyond numbers. Okay, so I give you an example. A set of cars, right? A set of cars. Okay. Set of cars. Now, I give you an object. Proton. What's the latest Proton car's name? Proton Persona. Proton. Is it a member of this? Proton. Yes. Proton. Okay. Pro 2. Right? What about Yamaha? I think Yamaha is motorcycle, right? So it is not a member of this. So you can know it's well defined. Whatever is well defined, whether it is a member or not a member, is a set. Okay. I can say a set of UTM students, right? So this object is Hana. Okay, you are a member. Shiham, you are a member. Like my staff here, who is not a UTM student, not a member. So it is well defined. Okay, that is also a set. Okay, another one is colors. Right? You can take any object, anything at all, doesn't have to be color. Let's say white. So white belongs to B because it's a color, right? What about chair? No, it's not a member. Chair is not a color. So this can be a set. Okay. What is a collection of object which is not a set? It's not well defined. Hannah and Shiham, you can answer. The others are welcome too. I'm not ignoring you, but what is it? All woman. Okay, this is a set. This is a set. This is not a set. Because how do you define all, right? Hannah, do I belong to the set? Am I old? If I put senior citizen, right? Then yeah, because senior citizen is defined to be ages 60 or above, right? That is a well-defined set. I'm not a senior citizen yet, but I consider myself old, at least older than all of you. All right, so enough on that. So you can read through the notation. We denote the capital letters A, B, C to denote sets, and the small letters to denote the members of the set. And I have mentioned element. So this is small letters, the member. This is element of. This is the set. We normally use capital. Yeah. If we have Y is not a member of B. So these are all very familiar to you, right? And empty set, right? Empty set, or just a set without anything inside, that's empty set. Okay, so if you have elements that is repeating in the set, you can just ignore. Like the first example 140, A, B, C, B, C, D, the repeating, right? So you can just ignore the repeated ones, you just write A, B, C, D. Okay, and it's very important when you put the like integers, right? Integers, dot, dot, dot has to be 3. Dot, dot, dot. Hannah, what that dot, dot, dot call? You remember? See how you
Probably mentioned.
I did, right?
Oh, yes.
Ellipsis. I remember the ellipse. Okay, you can Google. Actually, it has to be 3. Dot, dot, dot means it's following the sequence or following the pattern, but it does not end, or it ends at the end of it. It's very important when you type your thesis or project sarjana muda later, then it has to be on the ground, bukan kat tengah atas. Tengah atas, it has another meaning. Okay, so this dot, dot, dot is actually called this, right? So sometimes it's infinite like this, yeah? So make sure that you have this, but if you have in the middle, right? You have like 2z, you want to do like 0, plus minus 2, plus minus 4, this is also okay. All integers, right? And dot, dot, dot. This is at the end. Later on, or if you are taking modern algebra, you have the call like maybe Z10. Okay, something like this. You start with, maybe I put 100. Yeah. Start with 0, 1, 2, dot, 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 comma, until 99. Okay, so you have to have comma, dot, 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 comma. In mathematics, the comma and the dot and the full stop, it does mean a lot of things. If you have writing authors, right? You can Google later, but ETAL dot, meaning in Malay, it's dan rakan-rakan when you write so many authors. Okay, so you can write sets in terms of listing or in terms of writing. The example there, X is positive integers less than 100. So you can put three different types of this set. S is X is a positive integer less than 100. Okay, so you can write S, X in Z integers plus positive integers such that X is less than 100. positive integer, or you can write as 1, 2, 3, ... 99. So 3 different types of writing a set. Okay, move on. So this is called the listing. This is called the listing. Okay. And this is called sets construction. For this one. Or this one. This is the listing. Okay. Then you can define whether an object is in the set or outside of the set. There are more examples there. But you have to know this notation throughout the semester. Yeah. Okay. You have to know not only throughout this semester until you don't learn anymore. Because in PhD and others, you're still using this. Okay. Z. Maybe some of them are not in my notes, but these are the things that, oh, it is. We can start with Z plus, yeah? Positive integer. And so this is start 1, 2, 3, ... This is start from 0. Wait. Yeah. Constitutive or positive in 0. Some authors, they start n with 1. It depends, right? Because in the notes, we make it consistent that n start with 0. So if I give you n, I will make sure to put the 0 inside in the question, but we follow this. Okay. N is natural number, right? Natural number. Z is integer. If you remember, Hannah or Shiham, why we use Z? Because we use R real number, right? Q. Z, I have Q quotient. I have R real. Why is it Z? You remember or not? Just now I already put this. Tak ingat ya, Hannah?
Dia sort of macam di creator yang orang yang buat itu.
And the name is Zahlen. He's a German actually. German mathematician. He's the one that introduced, and he wants his name Zach. Why not I, right? Because the others, they use all the first letter. Why not I? Because I is normally used for others, like ideal, others. So they use Zach. It's very interesting actually to read a little bit about history of mathematics. We have a Muslim mathematician, there's a book, even UTM have that book. So it's good to keep one as a mathematician. This book has been published quite a long time ago, so there's lots of discount if you want to buy that. And they also have online. Buy online, or some of them they have ebook. Okay. All right, now subset, right? This is the whole set. So remember, positive integer, natural number, integers. Q is the rational number, right? Rational numbers, which is P over Q. P, Q in Z, Q cannot be 0. Any numbers that can be written as a fraction. And this is just all real numbers. And then we extend real numbers to be maybe complex number, right? And complex number is written as A plus BI, A be real, I is imaginary number, right? So this is the complex. Now we go to the subset. Not only you have to know that A is a subset of B because element of A in B, you have to know the real definition, because later on you might be needing this basic definition to prove something is a subset of something. Okay. Right. Okay. Maybe Hannah can screenshot and just share in the group. There are 3, 6, 8 of us in the class. Bagi yang lain jalan sikit. Definition 1.3 subsets. Okay, so how a set is a subset of another set? This is a subset. All right. A is a subset of B. Normally, if there is a definition, even in the book they put if, that means if and only if. Okay, if it's definition, even if in the statement of the definition it says just if, but actually it's if and only if. Sometimes they just put if. If in a theorem or proposition, if means if then, just one way. Yeah, so that's the difference. So you see, if then this is actually if and only if. Okay. X in A implies X in B. This is what it means. I remember during school, I learned about Venn diagram, right? So A is a subset of B, B is bigger. If you have element X in A, if it's in here, it has to be in the bigger one, right? But the bigger one, you might have Y in B, which is not in A. So the B is bigger. Okay, so we say A is a subset of B, or A is contained in B. Okay, what if it is not a subset? If A is not a subset of B, we put this. Okay, and you have proper subset, right? Some book put just like this, or cannot be equal to. Proper cannot be equal. If you put like this, it can be equal. So A is also a subset of A. All right, because if X is in A, of course X is also in A. That's a simple one. Okay, next would be, example is too easy. You just look through, but maybe I just leave one. Okay, if you have B is 1, 2, 3, 4, 6. A can be any of the subset, right? You can have a subset of just 1, or 2, or 3, or 4, or 5, or 6. That's a subset of just one element. Or you can have 1, 2, 1, 3, right? Of 2. You can have 3, 1, 2, 3, 4, 5, 6, and so forth. So many of them. 4, 5, and 6. So many subsets that you can put subset of B. Now, can we put the sets before the one that I put here as subset? Okay, you can put Z plus is a subset, actually proper, right? Proper subset of N, because N has a 0, right? Which is part of Z, right? Which is part of R, which is subset of C, right? So because this is starts from 1, 2, 3, right? This has 0, 1, 2, 3. This one is positive, negative of this one. This is all numbers, real numbers. Where is Q? Where is Q? Shiham, where is Q? Are you here? Where do I
Well,
put it? Here, right?
Yes.
So I put Q, R, C. Q, Z is in Q because Z. Okay. If Q is 1, right? If Q is 1, then it becomes Z, right? So like 6 is 6 over 1 or 12 over 2, so it's a fraction. Okay, done with this subset, right? Next is operations on set. Okay, the first one is union, right? Union. Okay, A union B is a set of X in A or X in B. When I put X, meaning X is in the universal set, right? You remember we learned about this Venn diagram when you put something like this, or some use universal for the whole set. And then you have A here, you have B here, right? And then you shade the A union B like this, right? So it's the union of these two. And we also have the intersection, right? X in A and X in B. So the intersection will be this in both, right? If it's union, it's in either one, right? Okay. When you have a common element, you don't write it twice. Okay, you don't write it twice. Okay, and then there's more examples there, right? If you have no intersection, like this. A intersection B is an empty set. They don't intersect. We call A and B a disjoint sets. Disjoint sets. Okay. All right. If you have so many union, right, you can just put O. So many intersection, you can put N. So if you have 3, A union B union C. If you draw, right, the union will be all inside the circle, right? If you want to put intersection, all intersection, it will be just this, right? This. A intersect B intersect C, because only this is in A, in B, in C for this one, all right? But if you want to write A intersect B or B intersect C or A intersect C, this is different. A intersect B will be, right, this whole thing. B intersect C will be this. And A intersect C will be that, like NI, the intersection. And this, if you write A1 union A2 union A3, you can write this as union AI, I from 1 to 3. Because the union, right? So A1, union A2, union A3. If you union dot 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 AN, you can put until AN. The same thing, the intersection. A1 intersect A2 intersect A3. Okay. Next is the complement. Complement of B with respect to A. Complement of A with respect to A. Okay, and this is called A minus B. Right? So if you have A, B, A minus B is this. A balik pula. A minus B is this. All right? That is A minus B. Which is also A intersect B complement. What is complement? Complement is A complement is U minus A. X in U, X is not in A. You learn this in set logic, right? So it's, if you just have A, right? A complement is all this U without the A. It's outside A. Right? So if you have A minus B, A minus the B, or A intersect with B complement. B complement is with all of this, but you intersect with A, so you get this. Okay. And sometimes for number 38, I think U minus A equal A bar. You have to shift it a bit. And in this, we can use also this notation, the bar, right, as the complement. Okay. There's also another notation called symmetric differences. Symmetric differences, which is not really common. Symmetric differences. Okay, there is a plus, but the circle. X in all U, X in A, and X not in B. Or, there is an or. X in B and X is not in A. Okay. Right. So you have X in A not in B. X in A, not in B is this. X in B, not in A is this. You can rewrite this as equal to A union B minus A intersect B, right? A union B minus A intersect B. So this is what we call symmetric differences. Okay. Next is the algebraic properties that we have on sets as we have on the operation, the normal operation of numbers, okay? Like commutative. So we go to the operation, yeah? Set. Right, so A union B is B union A intersect B is B intersect A. This is called the commutative. This, and then we have A union B union C is A union B union C. A union B union C equals A union B union C. Okay, this is called the associative properties. Associative. Okay. Then we have distributive. All right. A union B intersect C is A union B intersect A union C. Oh, I do the union first and then intersect. If I put intersect there, that becomes here, right? Oh, this one you can also have intersection, yeah? A intersect B, intersect C. This is what I mean. Sorry, this is the same, right? I didn't mean this. This is the same. A intersect B, intersect C. Is A intersect B intersect C. Okay, betul. Ini tadi sama. Copy. Okay, so this is A intersect B union A intersect C. Okay, you've seen this before. Okay, then we have idempotent properties. Idempotent properties says that you union A with A is just A, right? You intersect A with A is just A. So that's the idempotent property. Okay, and then the properties of complement. If you take the complement of A, you take again, you get A back, right? A complement is just A. What about A union complement? A union the complement will be the whole universal set, right? Let's see. First, I said A union A is A because there's nothing new. A intersect A is also A, all right? And then I said A complement again is A. Take A, outside that, you got A back. A union the complement. This is A, this is U, the outside is complement. A union the complement is the whole universal set. A intersect the complement, empty set. Yeah, it's the empty set. This is all about complements right now. The empty set complement is U. U complement is empty because there is nothing. U is the universal set. Okay. That is small. A union B complement is outside. This is A complement union. Oh no. I think it's A union B. A union B is this. The complement is outside. The complement is this. Okay. That's A union B complement. A complement is outside there. B complement is outside there. So you want the intersection, right? So you will get that. And A intersect B complement is A complement union B complement. A intersect B is here, complement is outside there. I like to write here. This one. This A union B. So the complement is everything outside. These are all the complement. And A complement is everything here. B complement is everything here. So you take the union of those. Because it's anything except this part. Okay. All right. Okay. There is a list on page 41 about how to prove that these two are the same. So how do you show that this is equal to this? This is by showing using the definition. The definition of complement is X is in the complement, meaning X is not in the original set. So I will show you one example and then you can look at the rest. How do you show? How do you show X is in? Oh, sorry. How do you show? To show A union B complement equal A complement intersect B. Okay, so how do we show it? X is in A union B complement. It's the same thing as saying, I will put like this, yeah? X is not in A union B. By definition. Okay. And this is X is not in A and X is not in B. Because you go here, you change this, right? Into N. This is all, but there is not, so you change when you want to distribute. This X is in and X is in B. And this is the definition of intersect B. Okay. This is what I mentioned to show, to prove with a definition. Okay. Just now we do properties of empty set. Now we do property for universal set. What is A union U? U is the biggest one. So you union with anything else, you don't get bigger. So this is just U. Yeah. And A intersect U will be A. Right? A is the smaller one. What about A union empty set? Nothing extra, right? So it's just A intersect empty set, nothing with this. So it's an empty set. Okay. So finally for today, this is called the addition principle. Okay, addition principle. If A and B are finite sets, then how do you find how many elements of A union B? This is A plus B minus intersection, right? Because you see, if you have A and B, if you want to take the element in the union, if you take A and then you take B, you have counted this twice. That is why you have to subtract one time of this, right? Because once you take A, you already take this one. If you want to add, you have to take actually just this. But if you take B, you take again, including this. So you have to subtract back the intersection. Okay. So this is what I have for today. And you can try some exercises, okay? And it's very common to ask question about counting from here. You are given, you remember, I remember in my class from 4, from 5, the question is about this student like to play hockey and badminton and football, right? And this, there's another one here. And there's a student who take all sports, and you have to count the number of students that take only football or only hockey, things like that. Okay, so any question before I stop from anyone? You don't have to turn on your videos. Okay. Okay, Nizam, Alia, Atif, Abid, Shakir, no question? All right. Okay, that's good. All right. Thank you very much.